What's going on, everybody? Mr. Cornell here wearing his lucky shirt right now because I made this video earlier and I thought I hit record, but I didn't. So I had to do the whole thing over again. So we're going to do it again, and hopefully the second time will be better than the first time, and it looks like I'm still recording, so I'm going for it. So what we're looking at today is exact values and cofunctions, okay? And we're going to look at two special right triangles. Today, they're not going to feel too special, but a little later on, we're going to be doing something called the unit circle, and that's when they're really going to become special for us. So today, we're just going to kind of explore them and the different ways that we're going to use them, okay? So here they are. Here are your special right triangle. One of them is a 45, 45, 90 triangle, and then the other is a 30, 60, 90 triangle with the two legs and the hypotenuse given to you for those triangles. Okay. So these are good triangles to kind of have in your memory bank a little bit. If you could try to remember these the best you can, it'll just help you a lot more down the road. So now what we're going to do here is we're going to kind of use these two triangles and we're going to find their trig functions here. So we're going to start with our sine function. And the first one they want us to do is to find the sine of 30 degrees. So if I come over here to 30 degrees, the opposite is 1, the hypotenuse is 2, so the sine of 30 degrees is 1 over 2. Second one they're going to ask us to do is to find the sine of 45 degrees, which means I'll come over to this triangle here. Doesn't matter which angle you choose to wear. It's still going to be opposite over hypotenuse, which is going to be 1 over radical 2. And what we're going to be doing here is we're going to be looking to rationalize all denominators. Now, when you're rationalizing a denominator, it means it doesn't want to have the radical in the denominator, so we got to get it out of there. The easiest way to do that is to take whatever radical is in the denominator, and it'll work for any radical, and you're just going to multiply it by itself. And we'll do that on both sides. And this is allowed because anything divided by itself is 1. So really, I'm kind of multiplying this by 1. But when you go ahead and multiply this, 1 times radical 2 is radical 2. And then over here, when you do radical 2 times radical 2 is radical 4. And then the square root of 4 is just 2. This is your answer rationalized. So the sine of 45 degrees is radical 2 over 2. All right, and the last one here is the sine of 60 degrees. The opposite is radical 3. The hypotenuse is 2. No need to rationalize because, again, the denominator is what you want to have the radical, so you don't have that there, so you're done. All right, and that's what we're going to do. So if you want to give the video a pause, try cosine adjacent over hypotenuse with the two triangles. Awesome. Otherwise, I'm going to go ahead and do them here. All right, so again, cosine is adjacent divided by hypotenuse. So you're going to be doing the cosine 30 degrees. The adjacent side is radical 3. The hypotenuse side is 2. The cosine of 45, we're going to notice it's actually going to end up being the same thing as the sine. So again, quick recap. We'll multiply whatever's in the denominator, which is radical 2. 1 times radical 2 is radical 2. 2 times 2 is 4, and the square root of 4 is 2. That ends up being our same answer. And cosine of 60 degrees is going to be the adjacent side, which is 1, the hypotenuse side, which is 2. And then the final one is our tangent, which is our opposite divided by adjacent. So the tangent of 30 degrees is going to be 1 over radical 3. So if you didn't give it a pause yet, and you're just kind of following along with me, you want to try to rationalize this guy, go for it. Again, to do that, we're going to multiply by whatever's in the denominator. And again, the reason we do that is because 3 times 3 is 9. The square root of 9 is 3. 1 times radical 3 is radical 3. So there's your answer, radical 3 over 3. And the tangent of 45, opposite side is 1, adjacent side is 1. 1 over 1 is 1. And the tangent of 60 would be radical 3 over 1, which ends up just being radical 3. Right? And that's what's derived from using these two triangles up here with their angles and the 3 trig functions. Okay? And now remember, you could always throw in those inversed functions. So if I wanted the cosecant, say, of 30 degrees, okay, it's an inverse, so you take its reciprocal, so it would just be 2 over 1. And we'll kind of look at that in a little bit. Again, good idea, try to memorize this the best you can, or at least have an idea of where these all come from. All right, so now, and this is why it's a little bit of a good idea to try to memorize that chart, otherwise you're going to have no idea how to find the exact value of the following expressions in simplest radical form. So if you look back at your chart, because you don't have it memorized yet, it wants the sine of 30. So if I went sine of 30, it's 1/2. So here would be 1/2. Then I would go ahead and do the same thing for the cosine of 30, and that's going to say radical 3 over 2. Now we have to add these, and I'm allowed to add them because their denominators are the same. So the 2 would stay there, and 1 plus radical 3 is just 1 plus radical 3. Simplest radical form, check, and this is the exact value. All right. B, cosecant of 45. Okay. The cosecant is the inverse function which comes from sine. So if I went ahead and looked at what the sine of 45 was, okay, so the sine of 45, that was the one that matched the cosine, which was radical 2 over 2 right there. That's radical 2 over 2. Now to get the cosecant, you take his inverse, flip them. So here I'm just going to write 2 over radical 2. And now he's going to get multiplied by tangent 60. So again, go back to your chart, and that's going to say radical 3 or radical 3 over 1. And now this is just multiplying. So 2 times radical 3 is 2 radical 3. And radical 2 times 1 is radical 2. And there you go. Oh, no. So now, again, what I have to do here is I have to rationalize this, okay? And on what, again, similar, take whatever's in the denominator, multiply it out. So 2 times 2 is square root of 4, which is going to be 2. And then 2 radical 3 times radical 2 is going to be 2 radical 6. And you can't simplify radical 6, so you're going to leave it like this. And remember, you can always, super simplified right there. 2 divided by 2 is 1, so there you go, radical 6, final answer. All right? Okay, so again, if you got lost, try to play it back, watch it again, see where I got all of these numbers from, and hopefully it'll start to make more sense. Or leave a comment and I'll get back to you. All right, so if f of x equals sine x minus secant x, what is f of 60 expressed as a single fraction? Okay, so again, it's not just throwing it into your calculator. So f of 60, f of x is like saying x is 60. So this is the same as saying, well, sine of 60 minus the secant of 60. And then what you'll do is you'll go to your chart, okay? The sine of 60 degrees is radical 3 over 2. Okay, now we got to be careful because this is secant. Secant comes from cosine. So we would go back, we would go look at cosine of 60 degrees, and it says 1/2. Okay, but we're not going to use 1/2 because he wanted secant, so that's 2. So then that's minus 2. If you want to have it over 1, you can. Maybe it'll make it easier. Now, unlike up here, where the denominators were the same, here they're not. So we got to kind of take it back to elementary school. Well, what number would I use to make these the same? And we would turn it into a 2. 2 times 2 is 4. And then down there is radical 2. So now I can, why did I write radical 2? Now I can go ahead and subtract these. 3 radical 3 minus 4. There you go there. Final answer. All right, so hopefully we're doing all right. Continue going here. Sine squared x. What is f of 45? So this is like saying x is 45. So it's sine squared of 45. Well, what is sine 45? Sine 45 is radical 2 over 2. And then what they want me to do is square it. So it's like doing radical 2 over 2 times radical 2 over 2. Okay, because it happened 2 times. This is going to be radical 4 over 2. That's going to be 2 over 2. Final answer, 1. No! Oh, man. See, my lucky shirt is just killing me today because I'm trying to do too much here because 2 times 2 is not 2 because I'm adding it. All right, so this is really, let's erase. Very unlucky. This whole video is just treating me terribly. 2 times 2 is 4, right? The square root of 4 is 2 over 4, and that's going to be a half, not 1. Okay, I think I'd have them all memorized. This is the second time I'm doing it. Let's double check and make sure I'm still recording. Yep, still good to go. All right, getting to the end here. All right, now let's take a look at cofunctions and what that means. So now, don't even worry about this part. I'll just fill it in for you. What we're doing here, okay, for the sake of explanation and know-how and understand what's going on, I'm just taking the sine of 20 degrees in my calculator. I'm taking the sine of 30 degrees in the calculator and just writing down the numbers that the calculator is giving me, the decimal places. So here's going to be 0.342. Here's going to be 0.5. Here's going to be 0.707. Right here's going to be 0.866. Over here I'm going to have 0.940. I'm going to have 0.940 for the cosine of 20 degrees, 0.866, 0.707, 0.5, and 0.342. So again, I just threw it into my calculator. Pause, write it down, and then we'll go to the questions here. Question 1. Based on the above table, when does sine A equal cosine B? Okay, so let me go back here so you guys can see it as I do it. So it's saying, well, when is the decimal point here the same as the decimal point in the cosine function? So I'm saying at sine 20, it's 0.342, and that happened at cosine 70. Then if I move over to sine of 30, which is 0.5, he matches up with the cosine of 60. If I went to the sine of 45 at 0.707, he matched up to the cosine of 45. If I went over to the sine of 60, he's going to match up to the cosine of 30. And finally, the sine of 70 matches up to the cosine of 20. There you go. So that is all of the times when the sine of A is equal to the cosine of B, and that was the point of me having all those decimal points for you there. All right, so now if you look at question B, it's asking you, well, what do you notice about A and B, okay, in these questions, okay? And if you look carefully, okay, they're asking about angles A and B, because remember here, that's representing angles. Here it's 20 and 70, 30 and 60, 45, 45, 60, 30, 70, 20. All of them, their sums equal 90 degrees, okay? And then that right there, that's what the whole cofunction thing is. All right, so if I wrote that for you here, A plus B equals 90 degrees when sine A is equal to cosine B. And remember, A and B are angles. So when they're giving you question C, and it says, based on the question above, if sine A equals cosine 25, what would the value of A be? So we said that A plus B, which in this case is 25, should equal 90. So then that means A should be 65, because 65 plus 25 equals 90. And if you really wanted to have fun, if you put sine 65 in your calculator, and then you put cosine 25 in your calculator, they would have the same decimal points. All right. Here is D. Okay, same thing. They're calling A now 2x plus 1. They're calling B now 3x plus 4. Okay, don't look at this as any more difficult. It's just going to be longer. And you're going to add those two angles and set it equal to 90. 2x plus 3x is 5x. 1 plus 4 is 5. Move the 5, and this is going to be 85. Divide by 5, and you're going to get a value of x to be 17. All right, so hopefully this helped for cosine functions, cofunctions. And here's a little summary for you. It'd be good to kind of read that over. And then a little fill in the blank here. The value of sine of an acute angle is equal to the cosine, okay, of its complement. So here's an example. Sine theta equals cosine 90 minus theta. So if I just made up an example here and said, well, what if theta was 30 degrees? Then you would just do the cosine of 90 minus whatever that other angle is, which would be 90 minus 30, which is 60. And then the same thing happens here. The value of cosine of an acute angle is equal to the sine of its complement. And here's your example here. And if, say, I took the cosine of 80, he would be the same as the sine of 80 minus 10. No, man. I'm going to have to change this shirt. I'm doing the answer in my head. It's going to be the sine of 90 minus 80, which is 10. Okay. All right, so there you go. That is finding exact values and using some cofunctions. The next lesson is going to be looking at the unit circle, the whole reason we have all of this here today. So stay tuned. So make sure you have those post notifications on, that you hit the like button and subscribe. And if you have any questions, let me know.